Hello once again to Grumpy Science. This is Mark Tommerdahl and Bob Dennis, your own personal grumpy scientists. And today we're going to talk a little bit about
current events. We like to stay on top of things, but we don't talk about politics. We talk about things like new papers that have come out and what they might mean and how interesting they are. And a new paper came out in the Journal of Medical Hypotheses, which is one of our favorite journals because they're allowed to actually speculate. You got to remember, a lot of journals now have gotten to where they only report the facts and
the take-home message
and the take-home message.
P-value.
Yeah, and you're never allowed to actually speculate or discuss, what the implications are. But this was that use of nitrogen fertilizers in agriculture is associated with per capita alcohol consumption. So we found that kind of interesting. And you look at it and you say the states with the largest amounts of nitrogen fertilizer going on actually are also the states where there's the largest alcohol consumption. So that leads to a couple of questions. Basically, why are these people drinking so much, Bob?
Well, it could be that the use of nitrogen correlates with something else, like the classic that you learn about in college psychology classes is there's a correlation between ice cream sales and violent crime, right? Ice cream sales go up, violent crime goes up. So like an uneducated person would think, well, we need to make ice cream illegal so we can get these violent crimes under control. But in fact, both of those things go up with warm weather, right? You get warm weather, you get more ice cream being sold, and you get more violent crime because people are hanging around outside all the time, thugging around.
It could just be that more fertilizer is used where more people drink.
It may just simply be that it's a cultural thing, and people tend to live in a certain place by choice, and they have a certain lifestyle.
Or maybe people are drinking a lot and making bad judgments about how much fertilizer they use.
It could be.
It could be that.
But this is why we like medical hypotheses, because they're not trying to prove something to you. They're trying to say, hey, well, here's something we noticed. So this is a discussion about science in general, right? Hey, here's something we noticed. It's really kind of, unexpected. There's a correlation here, right? So what is the p-value? You always see p less than 0.05 or something like that. The p-value is the probability that the thing that you're looking at is either just random noise, or maybe there's something not random. Maybe it's not due to chance. And the magical scientific gold standard of a p of less than or equal to 0.05 means that there's only a 5% chance that it's just some random coin toss kind of thing. There's a 95% chance that there might actually be something going on there that you need to study further. Unfortunately, in modern science, oftentimes that's where they stop and they say, I got a p-value of less than 0.5, I can publish it. But in real science, what that means is that's where you start, right? So the nice thing about this journal in this particular paper in medical hypotheses, it starts with this observation. It says, in fact, I'll read it to you, a 0.13 gallon increase in total per capita ethanol consumption with a p-value of less than 0.0125. And what that means scientifically is that there's only a 1.25% chance that that's just a random observation. So there's like a 98.75% chance, if you don't mind me acting like Mr. Spock for a second, the probability, Captain, is 98.7% that that's actually something real.
It's only logical.
It is only logical. Why you humans would consume ethanol is illogical.
What do you think the p-value is for someone starting to watch one of our videos actually finishes one?
I would say it decreases with time. I would say the probability that people will watch all of these from front to back decreases sharply as we get more and more bitter. Although we could be wrong. But that's my hypothesis.
So and how does this have anything to do with grumpy science and the things that we study? Well,
and it's not the ethanol connection.
Well, actually, it is.
Or is it?
Yeah, it is the ethanol connection.
Okay, then.
Whether or not nitrogen
universe.
fertilizer is making people drink more, or whether or not too much alcohol is making people exercise poor judgment and use way too much nitrogen fertilizer, we don't know. But we can talk a little bit about the effects of ethanol on plasticity.
Brain plasticity.
Yeah, and what is plasticity, you say?
That's what I was just going to ask, but you went ahead and stole my thunder. So go ahead and let us know, Mark.
So plasticity is your brain's ability to learn and adapt to its environment. So, and how do you study it? The easiest way to study it, what do you think the easiest way to study it is?
Brain plasticity?
Or the easiest way to measure it?
Oh, the easiest way to measure it.
Well, one way to measure it is to deliver a stimulus. And what do I mean by stimulus? Let's say we had a pen. It's like, let's say I want to
Go ahead, poke me in the eye.
We'll poke Bob. We'll poke Bob a few times. And if we poke somebody once, they feel it. Oh, it feels something. And it feels pretty big. And then you poke it again, it feels less. And each time you poke, you feel it less and less and less. Well, that's a really simple measure of plasticity. And it's a little bit like when you put your clothes on in the morning. That's the only time you feel them, unless you put on some really irritating wool, and that's your decision.
In a sense, you're tuning it out, right? It's a stimulus that your brain says, okay, it's in the background there, noted, and then it just it fades to background, and you don't pay attention to it.
And there's a lot of neurological disorders that have hypersensitivity issues. In other words, they aren't able to turn that stimulus down. And bright lights bother them. See, we can't edit, so everybody's going to hear me say that. And loud noises and textures see them rough, and they never can quite adapt to the environment very well. Certain percent of the autism spectrum is a little bit like that, and they have a real trouble adjusting sensory-wise to their environment. But so it's really hard to measure, or at least it used to be. What we do is we actually deliver stimuli and deliver repetitive stimuli to the skin. And any idea how we would do that?
With the brain gauge.
With our product placement here, with the brain gauge.
Not placing a product. It is the brain gauge.
It is the brain gauge. And by the way, there is a discount code hidden somewhere in the video.
It's not
and the word
science,
is not the word science.
But there is a word that if you use it on the Cortical Metrics brain gauge web page, you can actually get a discount.
I have to turn to the multimedia center.
This is multimedia command and control center.
Oh, we've got leftovers from another talk.
Yeah, there you go.
Get rid of that.
Well, that's because it has memory.
Yeah.
It has extensive memory on the medium control center.
Okay. We're just wasting paper.
That's okay. We'll recycle it somehow.
Okay. So anyway, let's say you deliver that first stimulus. And try to envision what it looks like inside your brain. So actually, we've done these experiments, but you go right inside the brain and you measure the activity there. And the activity the first time,
boy, you can
if you gave it a profile, oh, you can't. That's not a good pen.
It's a pen, dude. You got to use it.
All right, we got to work on our media.
Well, that's a complex marker that one's childproof.
There we go.
I can't use it.
There we go. So here, now we have a bump. Okay, so basically, stimulate the skin. And you get a little bump. Now, what do you think happens, Bob, if we stimulate it again?
The bump size goes down.
It does go down. It goes down a little bit more. A little bit more.
I know that because I'm a scientist.
He sat through a lot of this.
I've listened to Mark more than I want to say. I've heard Mark
but basically,
for a long time.
This goes
and
down.
The signal keeps going down and down. And are you still talking?
Yeah. Right. Whatever. It keeps going down. But not only does it go down, it actually changes shape. And so now, this is going to be blown up so you can see it.
The plot thickens.
And now,
the sombrero.
Now we go from this big, wide Gaussian distribution. You want to explain what a Gauss curve is?
No, I don't.
All right,
but it's a normal distribution. If you know what that is, then you know what that is. And if you don't know what that is,
okay, I'm drawing a line right here.
Check it out on Wikipedia.
What do you think that line is?
I know what that line is.
What is it?
That's sort of your baseline.
This is your baseline neural activity. So you have a certain amount of baseline activity. If you go in, jump in anywhere in your brain, your brain's always chattering. I mean, believe it or not, it's just chattering away.
Like a 6-year-old.
Yeah. Yeah, just it's sort of like at a cocktail party. I got all these things talking and talking and talking. Now you get a big stimulus, and it's like this initially, and that's say that's a very brief one pulse of a 25 hertz stimulus, so 1/25th of a second. Then you'd give another one, and actually this amplitude keeps going down. But if you look real closely at the shape of it starts getting extremely tight And what's going on here is that here you would say this is negative. You actually get negative activity. So what happens is this area is turning on. When it turns on, it makes the adjacent areas turning down. And really what's going on is, remember we talked about, it's just like a cocktail party in that really busy, crowded room, talking. Well, now somebody got an input. He's going to put one hand on one person next to him, another hand on the other. He's going to push himself up. Well, these are the short guys next to him that just get shoved down. The big guy pushes down small guys.
Mm-hmm.
So
this is your brain cortex activity, and it's being stimulated and focused here. So it's being focused to a narrower and narrower area. And part of that focusing process is, I believe it's called lateral inhibition, correct? Mm-hmm. And that means that it's actually suppressing brain activity around the area in the somatosensory cortex that's getting the stimulus.
So there's really two components of plasticity that you can measure. One is how much does this get reduced, and how much does this get contrast enhanced with a constant repetitive stimuli. You can measure both of those things, and they give you a little bit different measures and mean a little bit different things. They're very subtle. We won't talk about that. But what does that have to do with alcohol consumption and judgment or poor judgment? Well, what we found is that in a couple of things. One, in 18 to 22-year-olds that drink a lot.
College students.
Yeah, we had trouble getting approval for that study because it was a survey.
Yeah.
Oh, you can't condone underage
alcohol
drinking. Well, we weren't condoning it. We were just measuring.
Science, though.
We were just measuring. And in kids that drink a lot, and this is over 60 drinks per month, they basically they didn't get this change here or this change here as much. Their plasticity was significantly reduced.
Muted.
Whereas all their other measures look pretty much okay. Now, and alcoholics, like this is people who've been drinking for 20, 30 years pretty heavily, and we're talking about like 2 cases of beer a day or something along those lines, their plasticity shot. It doesn't.
Well, let me ask you this question.
But it depends on whether they're sober or not. If you have a functional alcoholic, a lot of times if they have just drunk, their plasticity will appear fine.
So this is my question. I've never actually asked Mark this. Mark would know. He's probably one of the only people who know this. And this is sort of showing it in this amplitude of the response in the cortex, and this is showing it in space, right? There's this lateral inhibition, and this is a physical location along the cortex, right? So the thing to remember is that as you get this vibrational stimulus, every single cycle gives you one of these, and in 25 little cycles, in 1 second, it goes from this to that, and you have to imagine it morphing, like going like this in 25 pulses. And so my question to you is one of the dimensions of plasticity that you're interested in, that actual dynamic effect? Like maybe somebody's plasticity would be lower after 25 pulses, but maybe it catches up after 50.
Mm-hmm. Actually, we've studied that.
I know you have.
So, and actually, you look at how long, and you deliver you deliver multiple stimuli at many different durations. Same stimulus, but you do it for 100 milliseconds, 200, 500 milliseconds, and a second. And what you find is very different changes. Minimum that we adapt is, or the minimum that we can measure that we adapt to is about 100, 120 milliseconds. You might find other changes, but that's how quickly you can entrain and start sharpening in fairly fast.
That's 1/10 of a second to 1/8 of a second. That's pretty quick.
Yeah, to a constant stimulus.
This is your brain plasticity happening on that order of magnitude of time, fractions of a second.
Right. And so what we generally do, and like what we do with the brain gauge, the standard measure that we use in non-research situations is half a second. And that sort of puts everybody, it sort of standardizes a lot of things. But if you wanted to cut it down and study it a little sharper, you would look at, okay, how much did I adapt at 200 milliseconds, how much at 500 milliseconds, and then draw a straight line.
Because this adaptation is a dynamic process, right? It doesn't just go dit, dit, and it's done. It's an adaptive process. More stimuli, more adaptation. And I think, there's also a decay too, right? You leave things off for a while and it tends to smooth back out, right?
Yeah. And then the main question to finish up on is, does reduced plasticity due to alcohol lead you to use too much fertilizer? but I think
well, that's an agricultural question of no small significance. However, we have run out of time, and even though I'm not drinking a beer today because I am operating heavy machinery yet again,
and I am drinking beer because I am operating heavy machinery, but
we have two different worldviews here. It's all about, scholarly diversity on the Grumpy Scientist, right? We don't always agree, but we agree to disagree. So anyway, anything else?
Nope.
All right then, we'll see you all later.